Hello everyone, I am going to explain question number 10th and question number 11th of exercise 7.1 of class 12th. The question 10th is find the derivative of log x plus root x square plus a square upon a with respect to x. So first we will assume it as y. Then before differentiating it, we will simplify it. So for that we are going to use the formula log m upon n is log m minus log n. So here this complete will behave as m and this a will behave as n. So log m upon n formula is log m minus log n. That's why log x plus root x square plus a square minus log a. Now we'll differentiate it again. Now we'll differentiate it with respect to x. So when we'll differentiate it, the symbol of derivative will come with y also and with this term and with this term. So now we will start the differentiation. So when we differentiate it, we are going to use the formula. The formula of log x is 1 upon x. So this complete, just think that it's only x. So when we differentiate log x, the answer is 1 upon x. But it's not only x, it's the it is the higher polynomial of x. That's why we have to differentiate with respect to x again by the chain rule. So we'll differentiate it again, and now here this a is constant because we are differentiating with respect to x. So except x, all other alphabet are constant for us. Now since log a is a constant, complete is a constant, and you know that constant differentiation is 0. So the differentiation of log a is 0, and here I hope it's clear how we had done. We had assumed it as log x, then log x differentiation is 1 upon x. That's why 1 upon x came here. Then because it's not only x, that's why we have to use the chain rule. We have to differentiate this again. Now when we differentiate it, this derivative will go with this x as well as this derivative will go with root x square plus a square. See the next step. So now this term, that is 1 upon x root x square plus a square, will write as it is. This minus 0 will avoid. Now this derivative will enter in the bracket and it will distribute to both. So here it will come as dx over x dx. But here this derivative came here, but this root I wrote as power form because when we differentiate it, we are going to use the formula here is x to the power n formula we are going to use. That's why in power form I wrote as root we can write as 1 upon 2. Now differentiation of x is 1, that's why dx over dx is 1. Now we have to differentiate it. So when we differentiate it, we will differentiate it with the help of x to the power n formula. So this complete will assume as x, and this 1 upon 2 is going to be n. So what is the formula of differentiation of x to the power n x n minus 1. So this power came with x. So 1 upon 2 will come here, that is n. Then complete we assumed as x. So 1 upon 2, that is n x n minus 1. So here we wrote like this, n x n minus 1. So 1 upon 2, then complete we assume it as x, then n minus 1. But it's not x. That's why we have to differentiate it again by the chain rule. That's why the derivative came with x square and a square. Now when we move further, this 1 upon x plus root x square plus a square we wrote as it is. This 1 I wrote as it is. Now here half minus 1 is minus half. Now when we differentiate it, this derivative will distribute to x square as well as to a square. That's why this step came. Now when we move further, this term came as it is, this 1 came as it is. Now minus half, since power is negative, so it will go to the denominator, and half we can write as root. So how we had done this? This is minus half. Minus is there, that's why it came in the down with this 2, and because of this minus sign it came down. Then this half we can write as root. So root x square plus a square. Now when we differentiate it, we will use again the same formula, that is n x n minus 1. So what is n for us? This time the n is 2. That's why 2x 2 minus 1. 2 minus 1 is 1. That's why 1 I not wrote. Now this a square is constant because we are differentiating with respect to x. So when we differentiate with respect to x, other alphabets are constant. So since it's a constant, so differentiation of constant is 0. So we are remaining with only 2x. Now this 2 and these 2 will cancel each other. Then we'll take here LCM. See the next step. This 2 and this 2 cancelled. Then here only x remains. So x multiplied by 1 is x. Then we'll assume here upon 1 and take the LCM. So when we take here LCM, this step will come. Now just observe properly. This bracket and this numerator is identical. So they will cancel each other. So we are remain with only this 1 and this term, that is 1 upon root x square plus a square. That's the answer. Now we'll move to question number 11th of the same exercise. Question number 11th is, we have to differentiate, find the derivative of log x square plus x plus 1 upon x square minus x plus 1 with respect to x. So when we have to differentiate it, so first I assume it as y is equal to log, then the complete polynomial. Now this log, it is in the form of log m upon n, and you know log m upon n formula is log m minus log n. That's why log m is numerator, log numerator minus log denominator. That's why it came in the form of y is equal to log m minus log n by using this formula. Now we'll differentiate it. So on differentiating with respect to x, when we'll differentiate it, the derivative symbol will come with all three. That's why it came like this. Now when we'll differentiate this log, we are going to use the formula log x is equal to 1 upon x. So when we'll differentiate it, this complete we'll assume as x. So log x differentiation is 1 upon x. So when we'll differentiate it 1 upon x, then derivative of, since it's not x, so we have to use the chain rule. That's why d over dx with complete differentiation of x square plus x plus 1. Then this minus sign. Now again we have to differentiate it. So we'll assume this complete as x. Now differentiate it. So 1 upon x, that is log x differentiation is 1 upon x. That's why 1 upon x square minus x plus 1. Now it's not x, it's the polynomial of x. That's why we have to differentiate it again with respect to x. So derivative of x square minus x plus 1. Now we are going to differentiate the brackets. So when we differentiate it, this derivative will go with x square, as well as this derivative will go with x, as well as this derivative will go with 1. So when we differentiate it, x square differentiation is, we'll differentiate with the help of x to the power n formula. So this 2 will come in front, that is n x n minus 1. So 2x, 2 minus 1 is 1, so I not wrote here 1, and differentiation of this x is 1 and differentiation of this 1 is 0. So I hope this step is clear. X square differentiation is 2x by using the formula x to the power n, and x differentiation is 1 and this 1 differentiation is 0, and the denominator I wrote as it is. Then this minus symbol. Here again when we will differentiate, we will use the formula x to the power n. Differentiation of x to the power n is n x n minus 1. So 2x n minus 1 is 1 minus 2 minus 1. That's why. Now x differentiation is 1 and this 1 differentiation is 0. So I note out here 0. Now finally take the LCM of denominator. When you will take the LCM, both brackets are different. So both brackets will come in as LCM. Now this bracket will multiply by 2x plus 1 and this bracket will multiply by 2x minus 1. Now open the brackets. When you will open it, you will find the answer like this. And in down, I grouped them. I took x square plus 1 in one group and x square, here also x square plus 1 in one group, other group is plus x and minus x. So it came in the form of a plus b, a minus b. A plus b minus b formula is a square minus b square. Again I am repeating, either you just open the bracket how we opened here, or to simplify, to reduce the steps, you just group them as a plus b, a minus b. So your a is going to be x square plus 1 and your b is x. So a square minus b square. Now down just use a plus b whole square formula, that is a square plus b square plus 2ab, and this minus x square as it is. Again I am repeating, to open this bracket use a plus b whole square formula, that is a square. So x square square is x to the power 4, then b square is 1, then 2ab. When you will do 2ab, you will get here 2x square and this x square as it is. Now here these terms, how we got these terms? By opening these two brackets here. So when we opened it, we got terms like this. Now cancel all the like terms with opposite symbol and add all the like terms. So you will get this answer. And finally these two also, just do plus minus, you will get this. Take 2 common. That's it, because after this we can't simplify it. So that's our answer. Thank you.